So 8, B, C, D, and E, B, C, D, yeah, B, C, and D, all were about arithmetic. Now we're going to focus on geometric. And I must say they're both actually similar in terms of difficulty. It's just the hardest thing you'll notice is just there's more formulas to now consider when it comes to these. Okay, so we know what a geometric is. Okay, it's when you're multiplying or dividing by the same amount. Okay, so generally with geometric as well, looking at these graphs, whether it's increasing or decreasing, the graph is not going to be linear. It's going to curve upwards or it's going to curve downwards. Yes, Joseph?
Sounds pissing me off to hear it.
Yeah, it's. I think it's the projector.
It's the whole session, sorry.
All right, I'm sorry, I can't turn it off until I turn off the projector. So this is our rule for a geometric recurrence. Geometric recurrence relation. So Vn plus 1 equals I'll go V0 actually, or Vn times R. Basic rule for geometric recurrence relations. Yeah, this one's the same thing, but what do we notice is the difference based on the signs here, guys. So I'm looking at these. What does that mean?
Less than.
So if your number is greater than 1, what's going to happen? It's going to increase, but if it's less than 1, it's going to decrease. Okay, so just remember that. Okay, and we know what R represents. Yeah, R is the common ratio, but the common ratio here is going to be different to how we calculate it normally. Okay, but just as a quick recap, for that common ratio, so if it's increasing, it's going to be 1 plus the percentage over 100. And if it's decreasing, 1 minus the percentage over 100. Okay? Those are the two basic ones that we need to remember for finding the R. But it's going to change a little bit later on. Okay, so just be mindful of that. All right, let's keep going. So what's the difference between compound and simple? So all the arithmetic stuff. So this simple interest is all the arithmetic stuff. Okay, and because we can say that it's adding the same amount each time. This is adding 25 each time. Even though it says 10%, so it's 10% of something, it's adding $25 each time. Okay, but if it's geometric, okay, you can see that it's not adding by the same amount each time. Rather, it's adding by a percentage each time. So it's a percent of the previous one. So it's basically like adding 10%, 10%, 10%. Okay, it's not adding by the same amount. It's just adding by a percentage. Okay, and you do that by multiplying by a certain number. So you can say over time, geometric ends up being giving you more money, or compound interest does give you more money compared to simple interest.
Wait, that 10% of the previous. Geometric is 10% of the previous amount.
Yes, and arithmetic, it's a fixed amount. Yeah, it's the same amount each time. So geometric is like 10%, a percentage of each amount. Okay, and you can see the difference there. The squares are your geometric, so it curves up, whereas the circles are your arithmetic. So it's just going in a straight line. Okay. All right. So a couple of things to remember. I did mention this rule just before. How to find that common ratio. So if it's increasing, it's 1 plus R over 100. And if it's decreasing, it's going to be minus. Okay. But for now, we'll just focus on increasing. V0 is the same. Doesn't change. So we all already know that V0 is the principal or the starting rate. Okay. And also, as Bella was asking before, why did I add the principal plus the interest? Well, remember, the interest is basically the amount that you've earned at the end. Okay, but if you want to figure out how much that is, you're going to go, how much do you have in the end? Take away, how much did you start with? Okay, just some things to remember. All right, let's do some of these questions. So Mark invests some money in an account with interest compounding annually. Keyword there, compounding annually. Every now and then you'll come across this and you might say monthly.
Yearly.
Or annually means yearly, yes, so just once a year. Or you might see weekly, or you might see fortnightly. if I asked you guys what those means or what those meant, how many fortnights are in here? Does anyone know? It's 26. How many weeks are in here? It's 52. How many months are in here? 12. Okay, so those are things that you need to consider when you do these questions. But when you see the word annually, it's fine. Just leave it as just how you've normally been doing it. But later on, we'll come across questions where you'll need to consider that there's months and years in there. All right. Question 1. Show by recursion that the balance of the investment after 2 years is this much. So using recursion, so this is the way that we've always been learning it. List out all your numbers and how you got them. So we're just going to do after 2 years. Okay. So 2000. V0 is 2,500. Easy. V1. So that would be V0 plus or times, sorry. And you can see the common ratio there is 1.075. Okay, so V1 would be equal to 2,500 times 1.075. So on my calculator, 2,500. Oops. Okay, 2,500 times 1.075. Is that correct? Yeah. 1.075, and that equals 2687.5. Oops. 687.5 or 0.50 because it's money. V2, same thing. Okay, same procedure. It's just going to be V1 times 1.075. So V2 be equal to 2687.5 times 1.075. Okay, just multiplying them together. So we're going to get this amount and multiply it by 1.075. So 2889.06. Okay, that's the first part. Working it out. So that's what it means to work it out recursively. I know you can just go on your calculator, keep pressing enter, and that'll give you the answer. Okay, but you need to show you working out like this. Okay, part B is now when we can use the calculator to figure out after 5 years. Okay, so part B, just use your calculator for that one. So start off with 2,500. Okay. And then you're going to multiply by 1.075 each time. So we're looking for 5 years. After 5 years. So 1, 2, 3, 4, 5. So after 5 years, 3589.07. 07, okay. 0.07. That's B. Alright, C. Nice and easy. At which end of the year will the investment be worth at least 4,000? So 4,000 for that one. Again, using your calculator, work out when it'll reach at least 4,000. So I already know that's year 1, 2, 3, 4, 5. So that's 6, 7. So on the 7th year, you'll reach 4147.62. So I'll write here on the 7th year. And the answer is 4147.62. So the question is at least 4,000. Okay, part D. Now, this one here, I think we've already done a little bit of it before. How to find or prove that the percentage is 7.5% per annum. Okay, so in order to calculate that, remember that rule, percentage, to find it. So that question is just saying, prove that the percentage rate is 7.5. Okay, so to get that, all you're doing is you're getting the rate, dividing it by, I think it was V0, and then times 100. I think that's what I had before. Is that the correct one? Was it the other way around? Times V0. No, that's to find, no, so the original one was this, R equals percentage over 100 times V0. But this time we're trying to find this guy. So what I've done, so what I did with this formula, and this is not really an official one, but you can use it. what I did was, it's going to be R divided by V0. Yeah, that's correct. V0, then times it by 100. So, using this formula to find it, percentage equals R divided by V0 times 100. You can actually then find the original 7.5%. So in this case, yes.
Can you just, you know how you find the percentage?
Yep.
Can you just reverse that?
Yeah, you can reverse it, but I think some people want to use a formula for that as well. So this is what I've used or what I've come up with. So my calculator, the R value is 1.075. Then divide that by V0, which was 2,500. 500, and then multiply that by 100. So, oh, that doesn't look right. Hold on, 1.075. Oops. Divided by, yeah. It doesn't look right, eh? Let me look at the formula I wrote. Where was it here? Sorry, peeps. Oh, okay. That was for arithmetic, my bad. We're doing geometric. So it's slightly different. I'm sorry. So remember, sorry guys. So this is for increasing. So there's going to be another new formula for this. So remember the R, to get the R value, it's 1 plus percentage over 100, right? Do you remember this? Yep. Now, to go back and find the percentage for that, it's slightly different, okay? It's going to be this. It's going to be R take away 1, and then times by 100. Okay, so it's slightly different. I remember now. So to get back to proving that the percentage rate is 7.5, okay, we're going to use this formula.
Not the other one.
Not the other one. This is for geometric now. Okay, so the other one was for arithmetic. So it's slightly different for geometric. Alright, so if the percentage or the common ratio is this, 1.075, so we're just going to go percentage equals 1.075, take away 1, put that in brackets, because if you don't put it in brackets, it's going to multiply that negative 1 first. So when you put that in your calculator, 1.075 take away 1 times 100, and it should equal 7.5. So the percentage rate is 7.5. So this is, I know, slightly different, but this is for, you should make a note what you'd use for geometric.
So is that for, so you know,
Yeah.
you know, just -1? Is it always -1 or you add some?
It's going to be -1,
Always.
but the other one, so this is where it gets a bit trickier. If it's, so that's for an increasing, but if it's decreasing, it's going to be 1 minus R. We'll get to that later. Don't worry. A lot. So this is finding percentages. Okay. Let's try this one, and then it'll make more sense as we go. Finding percentages. So, or for proving a percentage. So you'll get a question like that where it asks you to prove a percentage. Keep in mind, guys, this is Year 12 content. Okay, so the fact that you're all sort of getting it, yeah, I know, that means you're going to you're going to be very ready, very ready for next year. All right, let's do this one, and then this one, and then that'll be it for this lesson. Okay, shh. So, no. So this one here, Natsuko takes out a loan where the interest compounds annually. The balance of the loan after N years can be modeled in this recurrence relation. So this one gives us the recurrence relation already. So I know that that's V0, and this one here is my R value. Okay, show by recursion that the balance of the loan after 2 years is this much. Again, I'm repeating myself when I do this, but we've done this before. So L0 is 12,500. L1 will be equal to L0 times 1.0475. Okay, so that'll be L1 is equal to 12,500 times 1.0475. So I'm just gonna work that out recursively here already. So 12,500. So term 1.0475. Yep. So there's term 1, 13,039.8. So L2 should be L1. So this again is how we show the full working out for
I
this.
think it's, wait,
9-3.
I
Is
think
it-
it's 9, not 3, 9.
3. Oh, okay, sorry.
I think. I don't know if I'm right.
No. You are correct. Thank you. So that's going to be L1 times 1.0475. Therefore, L2 is equal to 13,093.8 times 1.0475. And it should be this answer. So let's just double check. 13,715.7. Good. Okay, cool. Part C. At the end of which year will the... So B. No, that was B. Yeah, B. Sorry, my bad. B, okay. Again, using the calculator recursively, you're just looking at it after 5 years. So you're looking at L5. So that's already L0, L1, L2, 3, 4, 5. 15,764.5. Okay. You don't have to write, actually, when you're working with money, I do like to put 0 at the end so that you know it's 50 cents, not 0.5. And then part C, at the end of which year will the investment be at least 18,000? Sorry, the debt, not investment, the debt. So what year will it increase to 18,000? So we're already up to, what's this?
5.
0, 1, 2, 3, 4, 5. So we're looking for 18 grand. 6, 7, 8. So the 8th year, it'll be 18,11,9.3 on the 8th year. And I'll put in brackets how much it is. So it's 18,11,9.3. And then part D, there is when we use that formula that I mentioned earlier to find or to prove the percentage. So the percentage rule is this. The R take away 1 times 100. Okay, R minus 1 times 100. So for this one, it's going to be the common ratio of 1. What is it again? 0.0475. Did I miss a number here? 1.0475. And then minus 1 times by 100. And answer. So make sure you use brackets for this. Minus 1 times 100. 4.75. Which makes sense. Okay. Easy. So that's all we have to do for these questions. Okay, last two for these questions is just writing the recurrence relation and how we write a recurrence relation. Remember, the recurrence relation just tells you how to get the next term. So for this one, it should look like this, V0. So tell me the starting term. And then Vn plus 1. You got to tell me how do you get the next number. So it should look like this. So it's going to be Vn times whatever the R is. Okay. So for part A or E, the recurrence relation for this question, V0, I can already see is 3,200. Okay, so let's start with that. V0 is 3,200. And Vn plus 1. How do you get the next term? Well, it's going to be Vn times. How do you get the R? Well, this one's going to be an investment and it's compounding annually, so it's increasing. Okay, so it's not depreciating, it's decreasing. So the R rule, remember, is 1 plus percentage over 100. So if we did that, it's going to be R equals 1 plus 6 over 100, and that'll equal 1.06. Sorry? So 1.06. There's my recurrence relation. F,
Wait, what the frick?
same thing, V0, I can see on my question right there, $10,000. So always start with writing the initial value, which is V0, and then Vn plus 1. I can see here that the percentage rate is 5.25. So it's going to be R equals 1 plus 5.25 over 100, and that will equal 1.0525 as a R value. Okay, these are your R values.
Pause real quick, so I'm gonna understand. Thank you. Me, please, sir.
Okay. That is basically it